Hello, and welcome to this video where we'll be going through case B of the types of discontinuities that exist for functions. Okay, we did case A already in the previous video, so if you haven't watched that, I encourage you to do so. So what is a jump discontinuity and how do we spot that in a sketch? Let us start the definition. Jump discontinuity will exist for a function g of x at some point x equal to c if the following happens. Limit as x approaches c from the left of g of x is equal to limit as x approaches c from the right of g of x. Sorry, they are not equal. In other words, we are saying limit as x approaches c of g of x does not exist. And actually there is a symbol for does not exist. It looks like this. Okay. So when your one-sided limits, yes, these are one-sided limits either from the left or from the right. So when your one-sided limits are not equal at the same point that you are approaching, then you have a jump discontinuity. So again here the word explains itself, and it's you jumping from one function to another function. That's how you can look at it. Okay, and to offer some examples, in that regard, let's look at the following. If you're given a partial absolute value function up to there, regard that as our C. And then from there, still in line with C, you now have a linear function. Okay, so you can see that the limit from the left as you approach C will not be equal to the limit from the right as you approach C. Okay, so there's a jump there. Okay, or if you like, a gap. All right. If I give you a partial root function, let's take that as our C. Okay, so you have a partial root function and a partial parabolic function. All right. So again, when you approach C from the left, you can see the limit will not be the same as the limit of approaching C from the right. Okay, again there is a jump or a gap. So graphically, this is how you spot a jump discontinuity. And again, when it comes to the functional value, g of c does not have to necessarily exist. The essence of this discontinuity is really your one-sided limits, and if they are not equal, then you have a jump. There's a jump discontinuity that one can observe in the progression, the behavior of the function. Okay, if the limit does not exist, basically that is what we're looking at in terms of jump discontinuity. So yeah, this takes care of jump discontinuity, but we can also link this to physics. When you look at vertical projectile motion, and there's a ball that is bouncing, and you are drawing a velocity time graph, you usually have something of this sort, where that represents the velocity of the ball that, of course, decreases over time until it comes to rest. But this is an example of a jump discontinuity, where the limit from the left won't be equal to the limit from the right at the same point. Okay. So this is your velocity time graph in physics. So that takes care of this presentation for jump discontinuity. We're moving on to the next video now that has to do with the removable discontinuity. I'll see you there.